Hello everyone, I'm Aaron from DataStax, and I'm here today to take you through evaluating your Cassandra cluster for migration to Astra DB. And specifically today, we're going to be looking at examining your current application's behaviors. That way you have some idea of what work awaits you as you move forward. All right, let's go. So our agenda is pretty simple. We're going to have a look at the application's peak usage times. It's kind of important to know when the application is really being used a lot, and also important to know for migration purposes when it's not being used so much. Of course, if you've used Cassandra for a while, you understand just how important queries and query-driven data modeling is, so we're going to examine that as well. Compaction strategies change up a little bit depending on which version of Apache Cassandra you're running on. So we'll talk a little bit about that. There are some changes with consistency levels inside of Astra DB that you do need to be aware of going forward from the application side. And then, of course, we'll talk about vector search as well, because that's kind of the hot item right now. So, of course, the whole idea is that we're talking to you. We're talking to big enterprises who maybe have been running Cassandra for a little while. And what you're going to find is some of those big enterprises, and those of you who I'm talking about know who you are, you tend to have applications that have been around forever. And in this case, maybe you have an application that's been around since the 2.2, 2.1, or even the 1.2 days of Apache Cassandra, and you're looking to modernize it. To find an example, we actually went back through the archives of DataStax and found the good old Killrvideo. We're going to have a look at Killrvideo from the perspective of, hey, this is a legacy application we have running on Cassandra. What does it take to migrate this into Astra DB? The idea is that Killrvideo is a YouTube clone, and we're going to go ahead and look at the different ways that video data is stored in our data model and examine what we need to do to move it over. So in terms of peak times, we want to understand the usage frequency of our application. We want to understand, what latency and performance and throughput and what all that looks like at different times of the day. That's why it's important to check out some of those metrics and just see which times of the day your application cluster is working the hardest, and maybe some times of the day that it's not working so hard that, that maybe we could do some data migrating or data movement at that point. So again, go to your observability stack, look for those heavy and low usage times. As I already mentioned, Cassandra requires a query-driven modeling approach. So in terms of Killrvideo, that means that, we might have queries where we pull back videos by their ID. We might have comments by video, and we might also have comments by user. So that could be a little bit of a difference too. We might have, different tables for both of those queries. Actually, in Cassandra, that's pretty common. And if you've been around since the early days, you may remember that Killrvideo does use the counter column data type. But it's important to remember that with counter columns, you cannot use the insert statement, you need to use the update. This is just one of many considerations you may have to remember in terms of your queries and what the underlying tables look like. Another thing to consider is your existing compaction strategies. Now, if you remember from Cassandra, size-tiered and leveled compaction have been around for a while. We also have time window compaction that was introduced in Cassandra. I want to say it was like Cassandra 3.7 or 3.6, somewhere around there. It actually replaced the original date-tiered compaction strategy. And a big shout out to Jeff Jirsa, who actually wrote time window compaction. But for Astra DB, we really only have one type of compaction strategy, and that's called the unified compaction strategy. Now, you can implement the other existing compaction strategies, but, we really do encourage you to use the new unified compaction strategy because unified compaction strategy can be configured to work like all of them. and it takes some of the guesswork out of creating an initial table. So here, real quick, I'm going to demonstrate the new unified compaction strategy at table definition time inside of DataStax Astra DB. So if I take one of my tables in Killrvideo, let's say I take comments by video, I can say create table comments by video, and we'll say video ID, and that's going to be a UUID, comment ID, time UUID, and we'll say comment text, user ID, UUID. For our primary key, we'll say video ID, and we'll say comment ID. And then we'll say, close it up, and say with clustering order by comment ID descending. All right, so now you notice I haven't specified a compaction strategy. So if I just press enter and this table creates, let's go ahead and describe this table and see what happens. As you can see, the unified compaction strategy is the new default. So really, when you're creating new tables inside of Astra DB, that's the one it will default to. And this one does have some more advanced settings and configuration that'll help you get it to behave more like leveled compaction or time window compaction if you want it to. Consistency levels. Hey, everyone who's used Cassandra for a while, you remember how to query at one and quorum and local quorum. All, if you want to make sure that you're getting all of your replicas back and maybe even force a reader pair. Any, hey, as long as you're getting anything back. Well, Astra DB is a little bit different. Astra DB has some guardrails that take some of those consistency levels out. So levels like 1, local 1, and any simply do not exist in Astra DB. That's going to be important to remember, and you may have to adjust your application accordingly. Of course, vector search is kind of the hot thing right now with GenAI and RAG applications. Apache Cassandra 5.0 comes with JVector version 1. DataStax Astra DB already has JVector version 3. So by migrating your RAG application that runs on Apache Cassandra to Astra DB, you're going to get some increased throughput and increased performance just by switching to a newer version of JVector. By the way, if you haven't checked out Jonathan Ellis's GitHub account for the JVector repository, I highly encourage you to do so. So yes, this video is short, but again, the idea is simple, that before you migrate from Apache Cassandra over to DataStax Astra DB, make sure that you examine your cluster and you understand the nuances of the application and what it needs from the Cassandra side in order to be successful inside of DataStax Astra DB. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you, and have a great day.